Assalamu alaikum everyone. I am Mohammed Hamza. I am the WebEx host of the event. I think we should start the session. So over to you, Dr. Ghalib. Kindly unmute your mic. The mic of all attendees are already muted. So if you have any question, kindly put in Q&A box. If you have any query related to technical issues, you can drop that in chat box. Thank you very much.
Okay, Assalamu alaikum, and very good morning to all of you. I'm delighted to welcome you all this morning to the workshop on big data and cloud computing. And I must thank all of you from different parts of the world for being here today with us. So uh, we are pleased to able to welcome to all of you at Al Khazmi Institute of Computer Science and IT. And I hope that you will enjoy this event today. So the event is on big data and cloud computing, and you know that big data has been a tremendous success for last more than a decade in both industry and academia, and that's why we have organized a workshop on this very interesting research. So today we have basically we have two speakers. We have invited two speakers in today's event. The first one is Dr. The first one is Shui, and he would deliver a talk on big data privacy from network and artificial intelligence perspective. And the second invited speaker is Dr. Amir Mahmoud, and he will be addressing on challenges of building Urdu language speech engine using open source tools. So, in this event, we will formally start with the recitation of Holy Quran, and then I will invite the director Mahmood to say a few words on this event. So, let's start with the recitation of the Holy Quran.
بسم الله الرحمن الرحيم. In the name of Allah, the entirely merciful, the especially merciful. اقرأ باسم ربك الذي خلق. Recite the name of your Lord created. خلق الإنسان من
Jazakallah. And now let me invite Dr. Waqar Mahmood, Director, Institute of Computer Science. Center of Excellence for Research and Development in Lahore. And Dr. Waqar is also Director, Center of Energy Research and Development at the about optical communication, processing, network systems, wireless systems, optimization, power systems. Recently won research funding in a number of technologies as a writer of the Untitled Lahore chapter. Welcome Dr. Waqar Mahmood for Waqar Mahmood.
Thank you very much. Can you hear me all right?
Would you please mute your mic? I mean,
Yeah, it is unmuted. Can you hear me all right?
Yes, sir, we can hear you.
All right. Thank you very much. Thank you, Dr. Ghalib. There is some, I think, disruption on Dr. Ghalib's end on the internet side. We need to check that out. I hope maybe we need to turn off the video to keep the communication smooth. I hope. Well, thank you very much. I'll begin by thanking the speaker, especially Professor Shui, for patronizing the event today. Similarly, Dr. Amir for his talk and Mr. Kashif for organizing the event on behalf of IEEE Communication Society Lahore chapter. Today's topic, big data and cloud computing, is perhaps the most important topic of research and development for countries like Pakistan. It is a country going through a digital transformation. However, quite behind the advanced countries, but taking important steps towards digitizing its public sector. So the government has taken several initiatives. On the other hand, social media is also providing big data in the form of text, speech, and video content. So we got opportunity at our hand to make good use of it. Looking at the scenario worldwide, it is estimated that about 1.7 megabytes of data is being created every second for every person on Earth in this year, 2020. The rate will go further north from here in the coming years. The technological advances in micro and nano electronics resulting in availability of ever cheaper compute and storage facilities. Similarly, advances in optical fiber, satellite communication, and wireless communications has made large data transport affordable. These technologies, together with proliferation of IoT devices and sensor data, are creating huge opportunities of useful data becoming available for processing. Availability of big data centers, compute power, and high network bandwidth are empowering the revolution of big data analysis. Hence, the world is making headway towards predictive analysis of the big data through machine learning and AI. As I mentioned earlier, Pakistan has been a step behind the progressive countries in technological advancements. However, effective attempts to move Pakistan towards digital society are being made at this time. The sources of big data are varied and growing in Pakistan. Hence, the need to develop solutions that can take out valuable information to perform several predictive analysis is essential. Big data analysis can save us from tedious service tasks and play a major role in boosting the economy of our country. AI and machine learning are the best tools available at hand to run the analysis on big data. AI is considered as one of the disrupting fourth industrial revolution technology of the century. Therefore, the importance of these technologies are realized at the highest governmental level in Pakistan. President of Pakistan announced his initiative for artificial intelligence and computing in 2018. The objective of this initiative is to provide training to the youth of Pakistan on these disruptive technologies, making them knowledge workers for the enterprises in Pakistan and abroad. The Ministry of Information Technology has also been taking good initiatives in this domain, and they are working on developing AI policy for Pakistan through a task force consisting of members from industry, academia, and public services. The task force is proposing a national data authority, which will create policies and make arrangements to enforce the policy matters related to standards, privacy, and security in the country. Some of these issues will be discussed today by our keynote speaker, Dr. Shui from Australia. At our center here at the FOSMI Institute of Computer Sciences in UET Lahore, we have taken several research initiatives on big data analytics to provide services to the public and private sector in the country. Some of the applications developed by our institute are deployed in public services. For example, smart city applications such as acoustic node development and integration with the safety cameras in Lahore, extraction of vehicle analytics and crowd analytics from the camera feeds from the Safe City project are also deployed on an experimental basis. Similarly, monitoring social distancing in public places under COVID SOPs through CCTV camera is also deployed on experimental basis. Additionally, our team is also working on biological data that includes finding the genome sequences and analysis of the medical images to diagnose various diseases. Recently, our team has developed a system that has recognized the origin of COVID-19 in Pakistan through analyzing the biological data of affected COVID-19 patients. We work with the Center for Chemistry and Biological Studies in University of Karachi on this project. The institute is also providing services in the domain of multi-language textual data analysis, which includes sentiment analysis of textual data available on social media. We have special focus on the analysis of content available in the local language on social media. Dr. Amir will talk about some of the challenges in this domain today in his talk. Other areas of interest that we have in our institute are from the perspective of collecting big data and providing analytical services are energy, agriculture, transportation, education, and environment. Our speakers today are going to address some of the very important challenges being faced in big data analytics these days. In the end, I would like to thank again our speakers and organizers of today's event, and I hope the workshop today will be very useful for all our participants. Thank you.
Thank you very much, Dr. Kar. If the attendees have any question, then you can please write in the chat box and I will ask the speakers. Now let me invite Mr. Kashif Bashir. He is a chair of Communication Society Lahore chapter. He is currently chair IEEE Communication Lahore chapter. He has conducted 4 summer schools and has organized first Region 10 ComSoc summer school. He has also won Best Performance Technical Chapter Award 2016 and 2018 from International IEEE Communication Society Lahore section. He is also managing multiple international conferences, ICOS, ICEC. So let's welcome Mr. Kashibashi to have a few comments on this event. Thank you very much, Mr. Kashif, for being with us and sponsoring this event and supporting us in organizing this event. So now let's go for the first talk. Uh, um, Dr. Professor Shui. He is a distinguished lecturer of IEEE Communication Society, and he will join us from Sydney, Australia. He is a professor of School of Computer Science, University of Technology, Sydney, Australia. Dr. Yu's research interests include security and privacy, networking, big data, and mathematical modeling. He has published two monographs and edited two books more than 300 technical papers, including top journals and top conferences such as IEEE TPDS, TC, TIFS, TMC, TKDE, TES. All these are basically transaction journals and Infocom. Dr. Yu initiated the research field of networking for big data in 2013. His H index is 47, which is a very good index. He is currently serving a number of prestigious editorial boards, including IEEE Communication Surveys and Tutorials, IEEE Communication Magazine. He is a senior member of IEEE, a member of AAAS and ACM. So welcome, Dr. Professor Shuyu. So please.
Thank you for the introduction. Thank you very much for the introduction, and I would like to thank Kashif and the whole chapter of Lahore to offer me this prestigious opportunity to share our my talk with you about and also thank Professor Mahmood for her introduced high AI is information about digital trend, and in terms of AI, we do need people to share their data. My talk is learning about big data and privacy. Privacy becomes a big problem. So our research is based on this the trend. And in terms of AI, first of all, please allow me to introduce my university. It is called UTS, which is ranked 133 worldwide by QS this year, and our computer science is ranked 13. First of all, please allow me to introduce my university in ARWU 2020, which is ranked anyway. We are computer science. We are quite good worldwide by better news is we are very good at AI. Computer in science. Australia is ranked. Sydney is the city where I am. You can see the building from UTS. You can see the central train station. So we are in the center of better news is we are very good at AI. Very convenient in Australia. So my point is welcome you all. Sydney all is the staff and students. If possible, please visit us. You can see the building different UTS. Opportunities. The central we are in UTS. We are very open to welcome you to visit us, to study with us, and my point is collaboration with us. All the staff and the students, if possible, please visit us. Use different opportunities. We are in UTS. We are very open. I do some professional service, mainly to study with us, communication society, and collaboration. Thank you. Area editor, series editor, and so on. You may know my background is mainly China. I was educated in China for my bachelor's master's degree, so I have some connections there. As I discussed with the colleagues before the meeting, I collaborating with my background is local government in Zhejiang province, where it's very close to Alibaba. You know the company, degree, so about 40 minutes away by the high-speed train. The same state, 40 minutes away. Before the meeting, physically, I collaborate the local government. They encourage a lot of Zhejiang province for the digital economy. Alibaba. So they want people to do about 40 minutes start up companies with them. If you have an idea, 40 minutes away, you want to implement it, but you do not have local government money, you do not have space. A lot of they have for the digital economy to go there or collaborate
want
there
people to
with them. In this case,
startup companies with them.
The only condition
idea,
is once the company is
implemented,
established, they take 10% or 12%
they have
of the share.
You just
And all the
need to
others,
go,
they will
to
cover
go there
all the
or
costs.
collaborate there.
So if
with
you
them.
visit
This
China,
case,
please let me know.
The only
I can
the
organize
only condition
you
is
to visit
once
them.
the company is
Talk about
established, they
possible
take
collaboration
10%
in
or
different ways.
12%
Very
of
open.
the share. Then all the
Second
others,
opportunity
they will cover all the
I want
costs.
to
If you
I
visit
also
China,
collaborate
please
with
let me
some
know.
good universities
I
in
can
China.
organize
They
to
have
visit
some
them and
postdoc opportunities.
talk about
If you have a
collaboration
PhD degree
in different
in
ways.
to do
Very
postdoc,
open.
then they are welcome. Second opportunity, payment
I
is
want to
quite good.
talk to you is
40 US dollar, $40,000 US
universities in
dollar
China.
to
They
70,000
postdoc
US dollar
opportunities.
per year. So
You
sometimes
have a PhD degree, you
better than a
do postdoc, then
professor
they are welcome.
in China. So if you
Payment is quite good.
or your friends want to do
40
postdoc there,
US dollar,
please ask them
40,000
to
US dollar,
contact me
70,000
or contact us.
US dollar per year. So sometimes it's
Better. Okay, we're back to our business in China. So if you or your friends want to do postdoc there, control the time. Please ask them to contact
in
me
this
or
talk,
contact us. This is the outline. Introduction, challenges in big data privacy, AI for big data privacy. And at the end, I want to discuss some possible directions.
So
based
in
on
this
my understanding. Talk, this is the outline. The takeaway points for this talk is
in
2
big data
points.
privacy, AI for big data
Number
privacy.
1, big data privacy is a big
I want to
opportunity.
discuss some
We know
possible
AI
directions.
now is very hot.
Based on my understanding.
If you want to do research or if you want to do startup, AI is
takeaway
very hot.
point for
It's a
this
little bit
topic is
hard
2
to
points.
get into the
Number 1,
market.
big data privacy.
But big data privacy
We
is
know
just
AI
started.
now is very hot.
Golden
If
opportunity.
you want to do research or
Second point
startup,
of this
AI
talk
is very
because
hot. It's
big data privacy is a new business,
into
a new research field.
market.
So we do need
big data
tools
privacy
to deal with it.
It's just
Unfortunately, the tools are not
golden
there. So
opportunity.
we do need to improve
Second
the existing
point,
tools
of this
or
talk,
even invent
because
new
big data
tools
privacy
to
is a
deal
new
with
business, a
That's
new
in
research
terms
field.
of research.
But we do need tools to deal with it.
Unfortunately, the tools are not there.
For big
So we
data
do need
privacy
to improve
introduction,
existing tools or even invent.
new
The Science
tools
magazine has
to
a
deal
special
with
section about big
That's
data,
in
big
terms of
problem
research.
2014. The Science magazine is maybe the highest
big data
reputation
privacy
of
introduction,
our field. So if there is believe big data is a big
Science
problem,
magazine has
then
a special
I
section
believe it.
about big
And
data,
also
big
they have
problem.
another special section
2014,
called
the Science
big
magazine
data,
is
the end of
the-
privacy.
maybe
Big
the
data.
highest
They believe
reputation of
big
our field.
privacy
So
is a big problem.
there is
in
believe
the
big
age
data
of
is
big
a
data.
big problem.
So it is
then
a good
I
opportunity.
believe it is a
golden
and
opportunity.
also they have another special
jump into
section called big data, the end of privacy.
If you look at the big data privacy issue, then you can see
privacy is a big problem.
two
in the age of
perspectives.
data.
One is data
it is a
itself.
good
Another
opportunity.
one is the
Golden
collection
opportunity.
of data.
Let's jump
Two
into
perspectives. In our
if you
field,
look at the big
data
data
mining
privacy
community,
issue,
they
then
are
you can
the
see,
early people. They realize
two
that privacy
perspectives.
is a problem.
One is data itself.
Of
Another
course,
one is
other
collection of
fields include social
two
science,
perspectives.
psychology, politics.
In our field, the
and
data
so on.
mining community,
in
they are the early
2015,
people. They realize
there's
that
two big
privacy is a
AI professors
problem.
of America,
Other fields
Michael
include
Jordan
social
and
science,
Tim McHugh.
psychology,
They presented a survey
politics,
paper in Science called Machine
and so
Learning
on.
Trends,
in
Perspectives
2015,
and Prospects.
there's two
in
big
this
AI
paper, in this
professors
survey,
in
they
America.
look at the past, current,
Michael
and
Jordan
future
and
of
Tim
AI.
McHugh,
Of course, they mentioned that survey paper with the development of machine learning, our privacy is and very dangerous prospects. That's good news for us who are working on privacy. Because of past, because it is very important, so we have to do it. Of course, they mentioned that. Then with the development of machine learning, I was inspired by the very dangerous the papers I mentioned. So in 2015, I started to work on big data privacy. It is very important. So I did write a survey paper called Big Privacy. Big Privacy Challenges and Opportunities in Privacy Study. I mentioned. So in 2015, actually access. Good news is it is an open journal, so everyone access it. I paid a survey, 10,000 big privacy, $700 to have the copyright. So you can, if you have time, please have a look. Access. Okay, in this survey, I found that essential problem for big data privacy, I paid to find a balance between data utility for company and privacy protection. Copyright data. So you can, if you have time, so just have a look. Give you a simple example. Okay, now in this survey, COVID-19 is very annoying, very dangerous. Privacy. So if we can list everyone who has COVID, his address, his name, and so on, then people will give you very helpful for the healthy people to avoid 19 is this kind of annoying, very dangerous. However, if we can list it will everyone have a big privacy problem against COVID patients and so on. Then people will. How do we find the data utility and avoid at the same time protect the privacy? That's the goal of. However, us, it will when we research on big privacy problem. We need to find a trade-off with the COVID patients. It's so how do we find the data utility? We have been working in this area for 5 years. That's the goal. We have some understanding, some research on sharing. So I want to share. So we need to find a trade-off with the two sides. Maybe some of them are not that correct, maybe wrong. But I want to share with you. Working in this area for 5 years. We have some promote some young people sharing in this field here today. To do some solid work. Some of them are the current hot privacy topics, but the first one was location privacy. Or if I visit Sydney or I visit Lahore, young people, maybe I don't want someone else to know I'm in that area. It's called solid work. Location privacy. The current hot privacy topics, because of the social network, is very popular now. Visit Sydney or people don't want other people to know their location. Maybe I don't want someone. This topic has been exploited for a long time. Now I think it's almost done. The second hot topic is personalized. It's very popular now. People, although we have been research on privacy for maybe two decades, however, for a long time. Most of the research almost done. Suppose the second hot topic suppose that personalized. Everyone, you and me and the movie stars, we share the same level of privacy. Obviously, it's not true. 2 decades. However, most of the protection. Suppose that's the reason we need to study on personalized. Everyone, you and me and the movie stars, we share now the same level. AI is obviously in our daily life. So privacy protection under AI, that's the reason we need I want to mention a little bit about Federated Learning framework. Now, as AI is pervasive, we did some daily life personalized privacy protection. Use differential privacy. If you don't know differential privacy, mention a little bit about. If you want to release some information in order to protect your privacy, so we did your data to make it personalized privacy. Your privacy sort of protected. For example,
if you don't know
if I'm in Sydney,
if you want to release some information in order to
we are very
protect
close
your
friends,
privacy,
I will
we add
show
some
my
noise
exact
to
position
your,
to you. If
to your data
Bob
to make
is
it
not that close to me, then I may
sort of protected.
only let
For
him
example,
know
if
that I'm in
Australia,
in Sydney.
right?
But if there is another person, Chris,
if
we are
very
not
close
strangers,
friends, I will
maybe we
show
only
my
let
exact
him know
position
I'm
to
on
you.
the earth.
If
in
Bob
this way,
is not that
we
close to
can
me,
implement
I may
some sort of
only let
personalized
him know
privacy.
that I'm in
In our
Australia.
previous work,
If there
I
is another
graduated
person, Chris,
two
we are
PhD students,
not strangers.
both of them
Maybe we
work on
only
this.
let him know I'm
All
on the earth. So
the core
in
of
this
our
way,
method is
we
to
can
measure the distance
implement
between
some
pairs.
sort of personal.
If I want to release a data,
So
I need
in our
release
previous
data
work,
to you. I want to measure
graduated
the
two PhD
social
students,
distance between you
both
and
of
me,
them
then
work on
decide
this.
how much noise should I
All we,
input in
the core of
release
our
data.
method is to
That's
measure
our
the
work.
distance
If
between
you
pairs.
are interested,
I want to release
please
data.
visit
I
my
release data to
my
you. I want to
publications.
measure the social distance between you and me, then decide how much noise should I input in release the data set. That's our work. If you are interested, please go visit my my publications.
Sorry. So I looked at my. Okay, the current popular tools. First tool is cryptography, the traditional tool. Now people also use AI to add privacy protection. Okay, we do have a tool called differential privacy, which was invented for privacy only. First tool is that's cryptography, the popular tools. Now people also use AI to privacy protection. We do have a tool called differential privacy study on the privacy. Invented for what are the challenges only? In my understanding, we have three challenges, three leading challenges. First one is measurement of privacy. Second one is we lack of model for big data study. And the third challenge is we lack of tools for big data study. In my understanding, we have three challenges. If you want to study on first one is privacy, if you want to protect people's privacy, first you need to measure the privacy. For example, data. For the movie star, what's her privacy requirement? As a professor, what's my privacy if you want expectation? Study we have to measure the. If you want to protect currently, we have a few information theory based movie star. What's measure her privacy? For example, K-mean as a professor, K-alarmity or some entropy based social distance based. Currently, we have a few finding is that all the measurements are not direct measures. They are either indirect or relative or some entropy based so far, we do not have direct privacy measurement. One finding is the direct privacy measurement is quite hard. Why? Direct measures because they are either indirect, very soft, or relative. You know this gentleman, Isaac Newton, 400 years ago. So far, we do not have. I can calculate the movement of stars, but cannot measure privacy measurement is quite hard. Why? Medleys, happiness, privacy, those kind of concepts very soft, are quite soft. You know this gentleman. So far, Isaac Newton, we do not have good tools 400 years ago to measure them. Wrote, I can calculate the movement. If you say after 400 years, do we have any ideas how to measure those kind of concepts? Those kind of concepts. Yes, we do. Soft. The possible direction we do not have good tools simply study. If you look at privacy, or you find that it's not the job of a computer scientist. It should be the job of psychologists. Should be the job of the social scientists. Should be the job of the lawmakers. If you want to measure privacy, you do find that it's not the job of a computer scientist. It should be the job of psychologists. Should be the job of the social scientists. Should be the job of the lawmakers. We worked on it, but there is a big gap.
If you want
Second challenge about big data privacy
combine the knowledge.
If you want to study big data privacy, you do need to understand big data. We need to use a mathematical way to measure big data.
We worked on it.
Represent a big data set. Second challenge about big data privacy. So we have only tools,
big data.
we have only series.
We need to
Understand big data. The first
we need
tool
to use
in our mind
mathematical way
is graph theory.
measure big data.
If there is a big data set, for
big
example,
data set.
in a social network,
That's
everyone of
second
us
challenge.
is a node.
If we have
in the social network,
we have
Facebook,
series,
or if you and me are friends, then there is an age between
our
you and
mind
me.
is use graph theory.
If there is
map
a big data set, for
big
example, in a
social
social
everyone
network
of us
into
is
a
node.
graph, then we have a big
in the
graph.
social network,
Then you can use
if you and me are
theorems,
friends, then there is an age
mechanisms,
between you and me.
tools from graph theory.
If we map
explore the big graph,
Facebook
that's
social
the
network into
first tool.
a graph, then
Do we have
a big
problems?
graph.
Yes.
Right. Then you can use
The first problem is
theorems,
the bigger data
tools
related big
from
graph,
graph
is
theory
really big, too big. So
explore
how can we
the big
deal with
graph.
the volume issue?
That's the
Another bigger,
first tool.
tougher problem is
Do we have problems?
social network is a dynamic.
The first problem is
We are friends today,
big-
but
bigger
tomorrow
data
maybe
related
we are
big
not
graph.
good friends.
Really
So the
too big.
age between
So
you and
how
me
can we deal with
disappeared.
the volume issue?
Maybe in tomorrow.
Another
So the
bigger,
dynamics
tougher
feature, how can we
problem
deal
is
with it?
the social
Unfortunately, graph
is a
theory didn't
dynamic
tell us.
So
We I
are
do see
friends
some
today, but tomorrow
good
maybe
universities,
we are
good
not good
researchers,
friends.
they are
So
working
the
on
age
this.
between you and
But
me
time
disappeared.
varying networks, maybe in tomorrow.
So the
So we need
dynamics
tools.
feature, how can we deal with
In the previous
Unfortunately,
slides,
graph theory
we
didn't
used
tell us.
graph theory.
So
It is
I do see some
it
universities,
is
good researchers, they are
geographic
working on this,
method.
time varying networks.
So we also have
So we need tools.
algebra
In the
method.
previous
example,
slides,
matrix.
we used graph
We use
theory.
it is a graph mapped to a matrix. Then we can use
geographic
theorems in matrix method.
Right.
Unfortunately,
we
big
have-
data usually
we
high
also have
dimension data. The traditional matrix
algebra
doesn't
method,
work
for
well.
example,
We do need a new tool.
We use
the tool is there
a graph
mapped to
tensor.
matrix.
Then
So
we
it's
can use
if you
theorems
read
matrix.
if you study physics,
Unfortunately, big data usually high dimension data.
differential geometry,
Traditional matrix
high
doesn't
dimension
work well.
space.
So we do need
How
a
can we
new
deal with
tool.
it?
The tool
Albert
is there-
Einstein,
is there
they are very good at this kind of
tensor.
tools.
So it's if you read if you study physics
In computer
then
science, we also
tensor
from time or in
differential
communication,
geometry. Right?
you
So
see
high
information
dimension space.
theory.
How can we deal with
From time to time
Albert
we
Einstein,
use statistics.
They are very good at
Right.
this
So
kind
the
of
traditional statistics, we do not study the small probability. But in the
In
big
computer
data
science,
age,
we also
we do
from
need
time-
to
or
study
in communication, we-
small probability.
you see information theory.
Very small wave in
From
the
time to
share
time,
market.
we use
Statistics,
statistics.
mathematicians,
So
they
the
can
traditional
use
statistics,
mathematical tools
we do not
to
study
predict
the
it.
small
The tool is
probability.
called large
But in the
deviation.
big data
Is,
age, we
part
do
of
need to study
probability theory.
small probability.
That's
Very small
okay.
wave
If you
in
are
the share
interested,
market,
please
then
read this book.
mathematicians,
If you
they can
Google, you
use
can find this
mathematical
book
tools
of
to
large
predict
deviations for
tool is
performance
called
analysis,
large deviation.
choose communication,
Part
and
of,
computing.
probability
It is
theory.
free on the internet.
You can read it. Okay, if you are interested,
The third
please,
challenge
read
is
this
lack
book.
of
If you
mathematical
Google, you can find
tools
this book of
for
large deviations
big data
for
privacy.
performance analysis.
So far,
choose communication and computing.
we say cryptography
it is
is
free on the
not
internet.
invented for privacy. It's not
The
invented
third
for
challenge
share
is
a
lack
secret.
of mathematical tools.
The only
For
tool we have
big data privacy.
for so far privacy is this one
We
called
say
differential
cryptography
privacy.
is not
Appeared maybe in
invented
2005
for privacy. It's
by
it's invented
DeWolf.
for
He share a
DeWolf.
secret.
Right.
The only tool
is a
we have
professor in Harvard
for privacy.
Well, you say we lack of mathematical tools, then
appeared maybe in
do we collaborate with mathematicians? I did try to collaborate with mathematicians. I found that
now is a
it's
professor.
not successful because mathematicians and computer scientists
lack of mathematical
or
tools, then
we are in different
do
worlds.
we collaborate with
Right. So if you want to collaborate with them, it's very hard.
to collaborate with
So the only way I found
that
that it's
not
effective is
successful
transform ourselves
mathematicians
to
and
so-called
computer
mathematicians.
or
We learn
we are in different
their
world.
skills and used them
So
in our
if you want to
ICT
collaborate with
domain
them,
to
it's
solve
very
our
hard.
problems.
So the
I
only
share
way
maybe
I
not
found
right.
that effective is transform
Three, AI
ourselves
for privacy.
to
Now
so-called
AI is very hot. Right? Professor
learn
Mahmood
skills and
just
use
mentioned
them
that
in
digital
our
Pakistan
ICT domain to solve our
AI is
That's
I sharing is
maybe
a
not
big
correct.
push for the economy. However, bad
three,
news
AI
is
for
you see this guy
Now AI is
for the
very
Matthew,
hot.
he published
Professor,
2 papers in science
Mahmood
as a
mentioned
report
that
reviews.
Pakistan
In 2018, he in his
big
paper
push for the
published
economy.
in Science, the title is
However,
"As
bad
Artificial
news is
Intelligence
this guy
Become Alchemy."
for the
Means
he published
when
two
people do
papers in
AI,
science,
they don't know what they are
as a
looking for.
reviews.
For the result, they don't know. Just
in
put the
2018
data into the machine, feed the data into the
his
machine,
paper
and then
published in
we,
science.
we get
title is
whatever we
As
get.
artificial
That's
intelligence
2018.
become alchemy.
This year, he
Means
published
when
another
people do
article in
they don't know
Science.
what they are looking
Title
for.
is
For
"Has
the
Artificial
result, they
Intelligence?"
don't know.
Oh,
Just
sorry.
put the data
this,
into the machine.
This is
feed the data
2000.
into the machine.
This is
and then
2018 paper. This is
we get whatever
this
we
year's
get.
paper called
That's
"Core Progress
2018.
in AI Has
This year,
Stalled in
he
Some
published
Fields."
another
The conclusion
article
is
in science.
in the last
Title
20
is
years,
Has artificial
progress of
intelligence
AI
Oh, sorry.
is very limited.
Oh, this is 2000.
Well, that's because
this is 2018
progress
paper.
is limited.
This is
That's
this
on the
year's
other side,
paper.
we do need to
All
invest
progress
more
in
to push
AI
it up.
has stalled in some fields. The conclusion is, so in the
My
last
understanding
20
is
years,
AI
progress
itself
of
is hard
AI
to explain.
very limited.
So some
that's because
friends, colleagues are
progress is
doing
limited.
explainable
On the other
AI.
side, we do need
It
to
seems
invest
that
more
not
to
that
push it up.
successful.
So my
Problem
understanding
for
is
AI
itself is
for
hard
privacy
to
is
explain.
no theories yet. We do not have
some
theory.
friends, colleagues are doing
Or we do
AI.
not have tools. It seems that not that.
Here, I give you
an example.
Now the
If you
problem
look
for
at this,
AI,
it uses
for privacy,
Euclidean
no
space.
theory.
You see, A and
do
B
not have theory.
is A and B, AB. The distance between
Or we
AB
do
is
not have
less than this.
Here, I give
AB
you
is greater than distance of AC.
example.
But if you look at those
uses
in the remaining
Euclidean
distance,
space.
you will find that
see A and
AB
B
is less
is-
than AC.
A and
AB,
the distance between AB is
big
less
data
than
space is high dimension space.
AB is greater
If
than
we still
distance
use the
of
low
AC.
dimension
But
ways
if you look
to
at the
measure it, study it, obviously
in the
we have
remaining
problems.
distance, you will find that AB is less than AC. So
Well,
big data
you may
space
say,
is
okay, AI
high dimension
is
space.
so
If we still
popular.
use the low
Then how about
dimension ways
AI
to
research?
measure it, study it,
As
obviously we
you
have problems.
know that we in communication, in October last year, I did a small project.
You may say, okay,
I had to
AI
see
is
the top
is
3
so popular.
transactions
Then how about
of
AI
communication
research?
society. You see,
as
for the
you
early access
know that
papers,
we
for example,
in
the
communication,
Q1, right?
so
The total
in October
number of
last year,
papers
I
in
did
the
a
early access
small
stage
project. I
was
had to
30
see
papers.
the top
Only
3
2 are related with AI.
transactions
6.7%.
of communication
So
society.
the other journals, transactions
for the early
on
access
communications,
papers, for example,
transactions on
Q1,
wireless communications.
right? The total
The
number
early
of papers
access
in the early
papers,
access
the
stage
percentage is
was
say,
30 papers.
or around
only
5%.
2 are related
That
with
means
AI. So 6.7%.
the AI used
the other
in
journals,
communication
transactions
research
on
is
communications,
around 5%.
transactions on wireless
So
communications.
it's very small.
The early access papers, the percentage is say all around 5%. That means
Let's back to the AI for privacy in communication research. So far, the only tool for privacy is differential privacy. So people try to use differential privacy to neural networks. In neural networks, you have different rounds AI for privacy. Learning, right? So someone said, okay, in the last round, I insert for noise using differential privacy to protect privacy. Someone said, every round I will of learning, I insert noise to protect the privacy. All this, I think, is not the essential, not touch the essential of noise using differential privacy to protect the privacy. Now, a popular framework for noise AI privacy is federated learning. All this, I think, in the traditional way, if you want to do machine learning, so you collect all the data into the center, privacy, all the data in the same place, then you now popular turn on your machines to do framework for machine learning, AI privacy. Of course, then if you put your medical data into the center, then the center may be curious. All the data into the center, read your sensitive same place. Okay, in federated learning, let's say, okay, your machines to do your original data keep in your hospital. Of course, then if you put your medical data into the center, then the center may be curious. They may read your sensitive data. Okay, in federated learning, let's say, okay, then your original data keep in your hospital, then you can only learning on your local place. You only upload the parameters of the learning to the center, and the center aggregate the parameters and then broadcast the new parameters for you to go through the next round. Then finally, we have a trained model. You can keep the data in your local place. So sort of privacy is protected. This is the best framework for big data privacy. However, there's a different vulnerabilities for federated learning. For example, I just give you a few examples. One is a poison attack. So when you do the federated learning, for example, you may want to know people's habit using the internet or using mobile. They may involve hundreds or thousands of people to hundreds or thousands of mobiles to into the federated learning. Someone said, okay, I'm a bad guy. I joined the learning. I try to mislead. I put the wrong data into your for your learning to mislead your conclusion. That's called a poison attack. So how do we know? There are thousands of users. How do we know some of them are malicious? And also, say if this user is Alice, this is Bob, or this is Chris. Chris cannot see the data of Alice, but Chris at the server side, Chris can see the parameters uploaded from Alice from time to time, every round, right? Then this bad guy can use a new technology called GAN, G-A-N, use GAN to recover Alice's data. That means the bad guy at the server side, based on the parameter uploaded to the server, he can recover Alice's data. That's the second client data recovery. And also, we didn't mention the traditional attacks. So in the cyberspace, there's a lot of attacks. For example, distributed denial of service, information phishing, and so on, right? Some people are using neural cryptography. I'm not sure it's a new direction or not. Seems not that popular. People try to combine cryptography with neural networks, but seems not that successful so far. So if at this moment, because we do not have theoretical tools, so when you want to have a reliable result, you do need depend on theoretical solution and then
AI solution space. The result at the intersection is a reliable one. At the last section, I want to share some personal understanding about the future of the privacy research. I believe the most important tool is cryptography. If you look at the history of cryptography, at the beginning, they have symmetric encryption, right? That means you and me share the same key, then we can share a secret. Then they have the asymmetric key, so public key, then they have ABE, right? So a number of people, they can share the secret in the cloud. That's the history of cryptography. But now in the big data privacy case, when we release a big data, we released the big data to a lot of people, right? So you see, the cryptography tools cannot meet our requirement. So when I have say health information, I want to release it, I will release it to any people, right? So I don't know who will share this information. So you cannot use the symmetric key or public key or even ABE. So that means cryptography tool is not suitable for big data privacy protection. So that's my point is we need someone to improve or to invent a new encryption tool for big data privacy. That's my understanding. New tools, yes, we only have differential privacy. We do need new tools for big data privacy. Well, that's all from my talk. Thank you very much for your time and attention. And I would like to take some questions if you have. Thank you.
Thank you very much, Dr. Shu. We have a question from Dr. Muhammad Ashfaq Khan, and he is asking what kind of approach is best for imbalanced big data, especially in high-speed networks.
Can you repeat the question again?
Okay, so he is asking what kind of approach is best for balanced big data, especially in high-speed network.
Okay, thank you very much for this question. I think this there are some based on my understanding. Yeah, please.
We can take his question directly. Maybe he's raising. Let me unmute him, and if Dr. Ishaq is available, then he can ask the question clearly. Maybe.
Yeah, offer me more information, please.
Yeah, more. Yeah, sure. So let me unmute him.
Thank you.
Sir, can you unmute Dr. Muhammad Ashfaq? He is a participant in this event. Excuse me, Hamza.
Yes, I'm doing.
Yeah, please. Okay.
Okay.
Yeah. Yeah. So Ashfaq is unmuted.
Hello.
Yes.
Hi. Hi. Thank you for adding me, and thank you very much for whole panel. My question is that someone we have the in high-speed networks, especially in the intrusion detection system, we have the imbalanced data set. Especially we have the ICX 2012 and 2017, and few more ICX data set have the imbalance, and these kinds of data set have the large amount of data set, and how we can tackle the imbalanced data in intrusion detection, and which kind of approach is better for the big data to handle the imbalance problem in the big data.
Okay, thank you, Mohammed. Thank you for the question.
Thank you.
Um,
Welcome.
if you look at my publication, I did work on the intrusion detection, especially for DDoS. But 5 years ago, I pay more attention to privacy. What you mentioned maybe related with the concept called deep inspection. So we have a high, we have a network. There is a lot of data, a lot of packets. How do we do the detection? I'm not sure what are people doing now at this stage. So maybe I suggest you to search the digital library to see what are the ways that people are doing about this. Or you send me an email about the more information. I need more details. Then I can give you some help. I may not. Okay, thank you.
So we have another question from Dr. Muhammad Noman. So Hamza, can you please unmute Dr. Noman? He can directly ask the question.
Yeah, yes, I am. Dr. Naman, you are unmute now. You can ask questions.
That was a good presentation regarding the privacy. My first question is that how does federated learning differ from distributed learning in data center environments? My second question was that why we need new tools. Just you discussed on the last slide that we need new tools for encryption or decryption in big data. So why we cannot use the existing tools that are available? These were my two questions. And regarding the previous question, we asked that in big data, if there is an imbalance problem, then how we can cater. So in my opinion, the data which is coming from heterogeneous resources is already imbalanced. For example, some sensor will be sending the data in sporadic nature. Some devices may be sending the data in different pattern. Okay, and some may be sending the data at a high data rate, at a low data rate. So you can see that the data is already imbalanced. Okay, so maybe this is my opinion regarding the last question.
Okay, thank
you. The big data, the data which is coming from different resources is already imbalanced.
Okay, thank you. Thank you. Mohammed, for the two questions. First of all, I welcome you guys to contact me to see if we can collaborate on some publication or maybe generate some good ideas. Okay, first of all. Second, I answer the question. For your first question, you say, what's the difference between federated learning and distributed learning? I think they are very similar. Maybe just different names, right? So people, well, a different group of people, they prefer use different names. Then they can claim that I'm the father of this. Okay, I think that's my answer for the first question. They are almost the same. Second question, you say why we need to invent new tools for big data privacy. The problem is the new big data privacy is a new thing, a new field. So the existing tools, you can use it, but not very, when you use it, it's not very comfortable, right? You cannot use it smoothly. Sometimes cannot fix the problem smoothly. So that's the reason we need new tools.
Thank you.
Thank you.
I think Dr. Ishfaq has another question, so maybe we can take this last question.
Okay.
Yeah. Dr. Ishfaq, Hamza, can you please unmute Dr. Ishfaq?
He can write to mute or unmute his mic. Meanwhile,
Okay.
I have unmuted him.
Okay.
Please, you
Thank
can ask.
you. So, Dr. Ashfaq, please ask your question.
Thank you again. My question is that can we use the few shot learning for the big data, and in the term of big data we can handle big data with few shot, because in few shot we have the some limited amount of samples, and then we train our system, and can we go with the few shot in big data?
Oh, thank you for this question, because I'm not sure. What do you mean, field shot?
Few shot learning.
Okay. For this question, I'm not very sure, because we are also quite new to this AI security. So my group, we have 6 PhD students and some young young faculty members. So
Right.
we are only a small part of it. But if we do welcome collaboration, so especially for Pakistani colleagues, right? So
Right,
maybe
it's good.
yeah, please email me, then let me figure it out. I also learn from you. Thank you.
Thank you.
Yeah, thank you very much for your insight.
Okay. Thank you, colleagues. Thank you
Yeah,
very
yeah.
much. I'm very honored to have this opportunity to know you guys, and I welcome you guys to contact me, visit me either in Australia or in China. Thank you very much.
Yeah, thank you very much. Thank you for being with us. Thank
Thank
you.
you.
Now, our next talk is Dr. Amir Mahmoud from Al Khazmi Institute of Computer Science, UET Lahore. He will be delivering a talk on challenges of building Urdu language search engine using open source tools. He is an assistant professor at Al Khazmi Institute of Computer Science and the head of high performance computing and networking lab for last 5 years. He obtained his PhD degree in engineering from Department of Electrical Engineering and Computer Science from Technical University Berlin in 2012. And during his PhD, he interned with Dr. Walter Willinger, AT&T Research Lab at the Institute of Pure Mathematics, University of California, Los Angeles, USA in 2008 and 2011 respectively. So now let's welcome Dr. Amir Mahmoud for his next talk. Dr. Amir, can you hear me?
Yes, yes, I can hear you. I'm just setting up my slide. Okay, so everybody can see my slides?
Yes, please continue.
Okay. So thank you very much, Dr. Ghalib, for the kind introduction. So today I'll be talking on challenges of building Urdu language search engine using open source tools. We have been working on this project for the last 5 years, and I will be talking in detail about how to use open source tools to build large complex systems. So agenda of today's talk is that first I will talk about some history of search engines, and then I will describe that what are the global trends and the market analysis for the search engine. It's a $1 billion industry. Then after that, I will briefly discuss the anatomy of search engines. and then I will go into detail about the challenges that we have faced during the development of Urdu search engine. There are some challenges regarding data collection and then data management and search management. And in the end, I will briefly discuss the future plan for our project. So as you know that the search web actually emerges around 1990, and the first kind of a search engine was ARCHI query form. It was a searchable directory files. There was no index present at that time. And the second generation was Wondex, World Wide Web Wanderer. And the first thing that the new thing was the web crawler. So the web crawler was introduced for the first time in this Wondex, and this was developed to measure the growth of the web. And then in there was a new tool called Jump Station. So in that, the new thing was that the indexing and the search query system was integrated. So you can see that the first we have ARCHI. It was just a searching. You can just search files, and then we have a crawler, and then crawler afterward we. The first web crawler that was text-based, and it was used as the first full text-based search engine. And then, as you know, before Google, there were two major papers that came. One was on the PageRank, that was the PageRank patent, and in 1996, the rank text was used, that they were using PageRank patent. And then that actually paved the way for Google, and Google was offered in 1998. So as you can see, it's a very big market, and every one of us who are actually connected online, we rely on Google and other search engines to find the information that we need. So currently, as of today, as of August 2020, Google has a 92.05% of market share. And the second one is Bing, 2.83%, and Yahoo, 1.65%. And you can also see that there are some unknown names or relatively less known names for the general market. One is the Baidu and the Yandex and the DuckDuckGo. So they also have a significant market in the search business. So these are global numbers. So if we see that regional search engines, in the regional market, so for instance, in China, so there are multiple search engines available, and Baidu is one of the leading Chinese search engine. It has a 77% market share, and the rest one, Sogu, Xina, and the other one, they also have like some percentage of market share. Similarly, these search engines are, Google is not only the one search engine. In different countries, they have built their own search engines based on their national languages. So for example, in Iran, they have a Persian language search engine called Use. In Japan, they have a Japanese search engine, Big Loop. And similarly, in Korean, we have a Dom. And in Iceland, we have Light. And in Russia, Rambler and Yandex. So in Bangladesh, we have Cryptography. So there are efforts for developing regional search engines so that the regional content is and the search ecosystem can be developed. In general, search engine anatomy is like that. On one hand, you have a crawler. You need multiple crawlers to crawl the web. As you know, that the World Wide Web has a huge size. So that means that the crawler needs to visit every website after some month. And these crawler modules work independently, and they have different multiple requirements of compute resources and storages. And get data, and that data needs to be stored in some kind of repositories, which we call as a page repositories. And based on this data, there are multiple databases are developed. So, for example, there is an index module where the data is indexed so that we can query that data, and then we have a content analysis so that we can do some kind of a metadata analysis. So, for example, if there is a web page, we want to know that how fresh that web page is and how many bytes are in there, which languages are there. So that is the information related to metadata. So when as a user you query Google or any search engine, So what you do, you type in to your browser in your Chrome, or the query is then processed by the search engine, and then the data is requested to their data centers, and then they pull that data from the indexing. The results are shown back to the client. So this is a very high level picture of the search engine, but there are lots of complex modules and softwares running on the background. So let's try to see that what are the main components that are required for a search engine. The first thing is that we need a data collection, and data collection is not an easy part. So you have to start from a point, and which what we call as initial seed preparation. And Bing, they use bots. So Google has a Google bot, Bing has Bing bot, and there's an open source tool, Apache, which can be used for crawling. And similarly, for once you have the data, then you need to manage the data. And for data management, we need some distributed databases like HBase, or we need some data indexing mechanism. And as you see that there are multiple crawlers, they can bring multiple data from multiple sites, and that data, sometimes it happens that the one crawler and two crawlers bring the same data, and then the data is actually duplicated. So in the index, you need to make sure that the data is not stored duplicated. So you need some. And similarly, when you need to have a search, you need search management. So for example, if a user gives some queries, so you need to understand that what is the intent of the user, and then you need to respond back according to the requirement of the user. So ranking is a very complex thing, and Google and other search engines, this is their way of making money out of the search results. So let's see first the challenges in data collection. So for example, for a regional search engine, like for a search engine like us, first major challenge is we need to identify the natural language. So for example, if we have a document, we need to understand if the document is written in an English language, or if it is written in Urdu language, or Persian, or Arabic. So you need to look into every byte present on the web. So the first challenge is you have to actually search every website to find the web page, and then the second step is you need to understand that if this web page is written in what language. This is a very compute intensive and time consuming process. And then the second thing is that once you have the data, then you can do some analytics on it, and then you can see if the web content is monolingual or multilingual, so that you can arrange those documents according to different language requirements. So for this first, what we did two things. First, we designed a crawler specifically for Urdu language, and we actually developed cloud infrastructure so that once we crawl data, we will store in that cloud infrastructure. And for this purpose, we started a very large scale web crawling for Urdu content. The second challenge associated with this is that if we store all the data which is not Urdu related, then we need a huge storage. So just imagine that the scale of Google. They have multiple data centers around the globe, and they need huge storage. So for our purpose, we were not interested in keeping the whole data. What we were interested in that we visit a web page, we see if it is Urdu or if it has some parts of Urdu. We will store only that data, and then the rest of the data we will discard. So for that purpose, we used the CLD2 Compact Language Detector 2 module, which is supporting. It is an open source tool, and it can detect up to 161 languages. So once we run, once the data is crawled, then we actually run the CLD2 module in it on the fly, and then we see that what percentages of different content languages are there. So for example, in this example, for the first line, we can see that the whole language is actually in Urdu. So the CLD2 has detected, okay, it has 91 bytes of Urdu. almost 98%. And the rest of them are punctuations. And the second line, what you can see is that we have 81% Urdu, and then we have 17% English. And in the third example, we can see we have 51% of the bytes in Urdu, and then there's 37 in Persian and 10 in English. So it can detect all these. So we use this language ID tool, and then based on these observations, we develop our own language ID tool, and then we run both language ID tools to see that when we detect Urdu language content. With Urdu, there is a problem that it has the overlap with Persian and Pashto and similar languages which are written in similar style. So we actually had to optimize our language ID module so that it has more performance over the CLD2, because in CLD2 what we have observed was that they were mixing up Persian and Urdu. So we developed our own language ID module to avoid that problem. So for the seed preparation, whenever you have to start, whenever you need to build a search engine, you need to start, and the starting point is seed preparation. And for the seed preparation, what we did, we analyzed 200 plus terabyte of uncompressed data. These were like 2.87 billion web documents provided by a common crawl corpus. We took their 2016 snapshot and we analyzed that data using different Amazon Web Services, EC2, Elastic MapReduce, and S3. And based on that data, we extracted domains, Urdu domains. So based on those results, what we can see here is that there was what we found for the regional languages. There were top 8 languages were contributing like 7.26%, and there were different Chinese versions. And then what we found that the Urdu and Hindi has a very small share in the global share of content. And from the multilingual perspective, we saw a difference. What we found was that in the common crawl corpus, there were 60% of the web pages in which the only language was English. So they were exclusively English pages, the single language pages, and the rest were multilingual. And similarly, we have this distribution for other languages. What we were interested in was that as far as Asian languages are concerned, they are not. There are very few percentage of pages shown in these red color that was single languages. So most of the pages that we observed in case of Asian language they were multilingual. For example, if there is an Urdu page, there is also an English page associated with that one. Or if there is an Urdu page, then there is also Arabic page associated with that one. So we found that in case of English, it's easy that since most of the content is only in English, but in case of Urdu, we have to identify other languages as well. So we started with 500 unique domains that we selected from Common Crawl, and we use Apache Nutch 2.4 for this large-scale crawling. And we did crawling. Then in that, what we found was that in once we are running, these crawlers are running 24/7. So they have to run all the time. So what happens when if there is a power failure, then whole crawler state is gone. So we implement features. So for example, for every particular, after some time, every few documents, we store a checkpoint state. So if the power failure occurs, then we can actually go back to that point, and then we can, we don't need to start right from the beginning. We will start just from that checkpoint. So for this purpose, we use Hadoop ecosystem tools like Apache Base and Apache Hive to query. And we deployed it on our cloud infrastructure. So one of the problems that we faced while content parsing was that whenever you have a content present on the web page, you also have some content present on the sidebar. So normally what we, as a web search engine, we are interested in the main content that is shown in the green. So that is shown in the, not in the green or red. The green and red is actually noise here. So what happens is that when you crawl, these noise also actually appears in the data. So you need to clean. So for that, we developed a web article miner algorithm using boilerpipe. for Urdu content, which actually detects the noise in the data and then cleans the data. Why we are interested in doing this cleaning is that once this noise is present, it actually affects your ranking results, because user is interested in the main content. They're not interested in the side content. So once the content is present, so if you include that data in your main web content, then what happens that when the search results will be queried, you will get the wrong result. So in order to improve our ranking, we had to develop that content parsing algorithm. Secondly, in case of Urdu, there is a huge amount of data which is present in the form of images, and those images are not searchable. So for this, luckily we already had in our Center for Language Engineering, so they have developed optical character recognition, OCR for Urdu languages. So in this, what we happen, we get the images and then we can just convert them into text that is searchable. So we integrated this OCR into our search engine. So after getting the data with the crawlers, and we need to, the second challenge is we need to do some data management. So how do we store that data, and how do we actually index that data? So for this, we need to develop a real-time full text search, and we had to do some query formation and optimization in the search engine. Secondly, the duplicate documents need to be detected. The reason why we need to detect duplicate documents is that we want to have storage optimization. So if we store one document 2 times, obviously the storage requirement will be increased. And then the next thing what we want to do was that whenever we have a document, we would like to see that if it is a news document, if it is a blog document, if it is a religious document, so that the search results can be improved. So in general, data indexing is done using Apache Solr tool. So in the indexing is a process where what we do, we have, let's say we have multiple documents. In this case, what you can see, there is a document 1, document 2, and document 3. What we do, we first pre-process the to remove the stop words. These are the most common words. They don't have much meaning, so we just remove them, and then we store the rest of the words. So for example, what you can see here is the best word is appearing in the document 2. Here now we have an index that knows, okay, the document ID has 1 word, which is best, and it is present in the document 2. And similarly, we have this inverted index, which is prepared. It is a very compute intensive process. So just imagine that if you have a huge data, this process will take multiple hours or even multiple days. So for the domain identification challenge, we need to organize documents according to the type of content. So in the major challenge in Urdu domain identification was that there is a scarcity of high quality labeled data sets. So for example, if you need to identify that if this is a document related to sports, then you need to, for the machine learning algorithm, or you need to have a labeled data set. So for this purpose, we build. Another challenge is you don't have any classification models, and any processing method and text feature extraction techniques are not present for Urdu language content. So for this, we actually developed a machine learning algorithm to categorize a page into 6 categories. And these 6 categories, they work like that. You have random documents coming into a machine learning classifier, and then the classifier, based on the algorithm, based on our model, it actually classifies if this news is actually sports related, or if this news is health related, or if this news is technology related. So, and we have been using these domain identification in our search engine. We have different sections in our search engine, like health, science and technology, and entertainment. So we identify these documents and then we present in real time. So any document, if let's say if there is a news coming in, right now we will, on the fly, we will classify it and then we will put it into that particular section. So next challenge is the related to the search management. So for example, whenever you visit or whenever you want to search, you need to give input to the search engine. So in our case, the first input is the through keyboard, or you can write it in Urdu language. And the second, what we have done is that you can also do input through speech. So then in case of speech, so we have different challenges in case of text, and we have different challenges in case of speech. So Urdu have more alphabets than English, and then Urdu is also a complex language that once you write, the writing is not simple. So you have to make sure that there are no extra spaces. So if there is an extra space, the word can actually have a different meaning. Similarly, in case of speech, there are different accents that exist in Pakistan. So, for example, if you are in one region, people say the same thing. If you go to another area, they will say. And the challenge is to identify and handle those accent variations. And similarly, in the search ranking results, as I mentioned in my earlier part of the talk, was that the Google was based on PageRank. But if we apply Google PageRank or PageRank on Urdu websites, it really calculate, because as Professor Shui mentioned that big data means big graph, and if the big graph is not connected and there are some edges missing, then you cannot actually compute the whole PageRank. That doesn't mean anything. And similarly, another challenge in search management is the user behavior. So, for example, all search engines, or most of the search engines, what they do, they give personalized search. So, if you are interested in something, if you're doing queries in more on one topic, then they actually use this information to show you ads and monetize that information, and also to give you more better results that you are interested in. And similarly, we can provide safe search for Urdu content. So, for example, we have modules developed in so that we can detect profanity in the content or hate speech in the content, and then we can lower their ranks while showing the results. So this is what you can see. This is a speech-to-text system. This is Hamkarat Pakistan search bar. What you can see here is that you can query that will go to the Hamkarat website, and then we have an independent system, Urdu's speech-to-text system. We will get the result back, and then once we have the text, then we can just pull the data. We will query our index and then give the results to you. So there is you can also there is a bar, and you can test that yourself. So one of the challenges is the Urdu website ranking. The page rank failure for Urdu website I've already mentioned. It cannot be calculated due to broken link graphs, and also it has a problem that the values are sparse and cannot be normalized. The majority of websites, they do not have a good page rank. So we developed our own scoring algorithm using domain, quality of domain, and the quality of content for each website. What we call as the A rank. Here, what you can see is that there are one challenge is that you can see that multiple sites can have a similar document. So this is like a famous column writer. It has his column is published on two links or two websites. They have their main publisher, but the websites are two different. So we need to make sure that we have one copy of that one. So before deduplication, you can see the content looks like this, and after deduplication, the content looks like this. So this is a major challenge that we have to face to get data deduplicated. So we deploy MD5 and text profile signatures to identify deduplication. And similarly, for search results ranking, we deploy BM25 ranking model for document selection, and we score for every website. We have calculated a score, and if we find like a profane document, we rank them negatively. And if we have recent documents, we boost them by giving some extra ranking points. And if we are also working on getting the quality of Urdu content. And if the quality of Urdu content, we are developing our own metrics to identify quality of content, Urdu content, and we rank them high. So for example, we have different dedicated sections available on Urdu search engine. It is a web, books, religion, news, poetry, sports and videos, Wikipedia, and famous sites. So you can visit Hamkinar search engine on www.hamkinar.pk, and then you can use all that one. So from the ranking point of view, what we do whenever we receive a query, we first do stop words. We remove the stop words, and then we use our retrieval model, BM25. And then after getting the scores from the websites, we check the recency, and after that, if the document is profane, we just filter them out, and then we apply user-based ranking, and we do deduplication, and then we show the result. And we pull all these results based on our two repositories. One is the Hamkinar index, and the second one is the web analytics repository, where we see that which web page is actually visited most, and if someone is interested in more, we can boost those based on our contact analysis. So next, this is the portal that we have. We have just shown you the Hamkinar results for query Pakistan. You can see if you speak Pakistan or if you write Pakistan in Hamkinar search bar, you see the results, and these results are based on all those problems that we have already solved and built into one system. So these are the publications that that came out of our work based on Hamkinar search engine. So it's an ongoing effort. In future, we are using this platform. We are building a plagiarism detection system. So for example, for Higher Education Commission, whenever there is a thesis submitted to HEC, they don't have a mechanism to see plagiarism in Urdu language content. So now we have an Urdu search engine, and we have a repository of theses written in Urdu language and books. We can detect, based on this data, we can detect plagiarism if it is present in any new document. And then we are building a general indexing system for Urdu research paper. So right now there is no general indexing system present in Pakistan. So we started for all the journals. We started first for the Urdu language, but now we are extending it to the other Pakistani journals as well. And similarly, based on this data that we have, we are detecting fake news and propaganda present in the web documents. And finally, we are developing search as a service facility for e-governance and businesses. For example, if there is a web portal or for any government search, any government agency that they want search as a service, we can enable them on their website. So these are some of the ongoing work that we are doing based on Urdu search engine. So I would like to thank. These are all my slides. So if you have questions, so you can now ask.
Thank you very much, Dr. Amir, for giving us a very nice talk, very insightful information on search engines. We have a couple of questions. So let's start from Dr. Ishfaq first. Hamza, can you please unmute Dr. Ishfaq?
Dr. Shfaq, you can ask questions. Thank you.
I thank you very much. Can you elaborate the diagram that use the Hamkinar search engine in next one?
You mean this slide?
This.
Yeah. So what's the big question?
Here I am confusing the website scoring and.
Please speak loudly. I cannot hear you.
I am confusing about the website scoring here. How can you differentiate and?
Also, you mean that we see the website scores, right? Right. Okay. So for example, if you look at the let's take a general example. So if I use for any news, let's say I use BBC Urdu. This is one website. We have Dawn News, we have another site, and then we have multiple Urdu websites. So what we have seen is that there are some Urdu websites, they are contributing more documents daily. And there are Urdu websites, they are just, they're there, but they're not growing. So we check out these growing parameters and we see that how much their growth is, and then we score them differently. Because if you're contributing more documents, you have more documents in our index, there is a more choice that you will be searched more. So we score according to their number of documents, we score according to the number of quality of content, and we score number of their domain rank itself. So did I answer the question?
On the basis of visitor and on the basis of content quality.
Yeah, exactly. We see that which, for example, if there is a website which is very often visited, so we improve their rank, we increase their rank.
Right. Okay, getting you.
Okay, thank you very much. And next question is from Dr. Noman. So, Hamza, please unmute Dr. Noman.
Thank you, Dr. Amir. That was a very nice talk. My first question is that you're talking about the removal of duplicate documents. So which document will be removed if they are from different sources? For example, from one news channel, from another news channel. As one source may have a higher rank than another. Okay. And my second question is that if you are thinking about a page range sort of algorithm, okay, then why you are removing the duplicate documents? Maybe in future the document on that page could be used in ranking the page. Thank you.
Right. So really very good question. So one thing is that what we have observed in Urdu, in case of Urdu, was that people actually they copy the content without the permission of the publisher. So, for example, people have. I mean, this is the case that we are saying. I'm showing you this is not that case. In this case, the publisher is same, but they wanted to have more audience. They have two websites, and they are trying to increase their audience by just putting it on two websites. So in this case, what we do is that we select one with the highest rank. So that is actually understandable. But the second case is more dangerous, in which that anybody actually can make a portal, and then they will just show you the similar news. So in that case, that content is actually not a legal thing. So we even the publisher, they don't want them to show their content there. So they claim.
But how we can ensure that in this case this is a problem from the publisher's point of view? If we are talking about a situation where a lot of documents are being present in different sources and we are crawling those documents, so we are not having concern like this, that for this document we have a publisher sort of concern and these documents are legal. We are just crawling all the documents. So how we will ensure all these things in this situation?
Right. So we don't. So there's a difference. That one is that the results that we show in our final results, and the second is that if the document is present in our rank index. So we do keep that index document in our index, but we do them negatively. See the point? So as far as the calculation is concerned, the document is there, but as far as the results presentation is concerned, the document is not there.
And in how this removal of the duplicate documents will affect the rank of the pages or different websites as well.
Can you repeat the question? I couldn't hear it properly.
Okay, for example, you are going to remove the duplicate documents from some authentic sources or from duplicate sources. So in future, this duplication sort of removal could affect the ranking of different pages. So why you are going to remove these documents? Why you are not keeping all the documents?
No, we are keeping those documents. We are not showing them. We are, if we detect duplicate, we rank them negative. we just lower their rank. We keep them, but we lower their rank. They will not appear in the search result, but they will be with us in our index.
Okay, thank you.
Okay, so we have another question. Mr. Muhammad Ahmed Abdul Rahman. Hamza, can you please unmute Abdul Rahman?
Yes, I'm doing. Mohammed Abdul Rahman. Mohammed Abdul Rahman. It's Mohammed Ahmed Abdul Rahman. You are unmuted now.
Yes, he is Muhammad Ahmed Abdul Rahman.
Sorry, sir, there was some technical issues with my network. I was unable to hear some part of the talk. So it was a good talk, very informative. Thanks.
Okay, thank you very much, Abdul Rahman. So that's it from today's talk. So thank you very much all the speakers that they have given very insightful talk to the participants. And I must thank all the participants for attending this workshop. And I also thank the organizers of this workshop, Mr. Kashif and Dr. Wakar Mahmood, for making it possible for today's event. Oh, thank you very much. Let's conclude this event now.
Dr. Amjad from FAST with us. So if we can share the closing remarks. Dr. Amjad. Is there Dr. Amjad with us?